Geometry, Unit 5, Chapter 7, Section 2, Properties of Isometry. When a shape undergoes a transformation, an isometry is when that shape preserves its original size. This means rotations, translations, and reflections would be isometric, but a dilation would not be, except in the one-to-one dilation. So if this is my original shape here, this would be isometric, but a dilation would not be isometric. So let's see if some of these translations are isometric. So we're going to do this along the coordinate plane. X plus 5, y minus 2. Remember, that's also seen as a vector, 5, negative 2. So x plus 5, so let's A, B, C. So x plus 5. So we go over 5 on the x, and then y minus 2 to here is A prime. B, x plus 5, y minus 2, B prime. And then C, x plus 5, y minus 2, C prime. Now, since our shapes, since it maintained the shape, it is isometric. So let's do this transformation. A, B, C. Now, it's an interesting transformation. Look, negative x comma y plus 3. So I'm actually going to write down what my coordinates are. So A is negative 5, negative 5. B is negative 1, negative 2. C is negative 2, negative 5. So I'm going to apply this transformation. So A prime, negative x, so negative 5 times negative. So that's 5. Negative 3 plus 3. Sorry, negative 5 plus 3, it's negative 2. B prime, negative x, so it becomes 1. Negative 2 plus 3 is 1. C prime, it's 2. Negative 5 plus 3 is negative 2. So let's graph these. So 5, negative 2, that's A prime. B is 1, 1. Oops, my A is off. A is supposed to be down here, A prime. And C is 2, negative 2. And that is isometric. So what happened there is we did a reflection. Across the y-axis, and then we did a translation. All right, so the question here is, what was the transformation along the coordinate plane? Well, first we can see that it is isometric. Second, what is the transformation? Well, you'll notice that A, B, and C are maintaining the same orientation. So I didn't reflect it, and it didn't rotate it. So the question is, well, what did we do? Looks like it's just a translation. So how far down and how far over did we move? We moved over 1, 2, 3, 4, 5, 6, 7 back, and we moved 1, 2, 3, 4, 5, 6, 7, 8 down. So the transformation, I'll put this in vector form, was negative 7, negative 8. Now let's put it, oops, that should be a, and then in this form, x minus 7, y minus 8. So that was the transformation along the coordinate plane. Now let's look at this one. This one's definitely a little bit more complicated. But we can see that it is isometric. The shape is the same. It's just looks like it got flipped. It looks like it got flipped right here along the y-axis, so that was a reflection, and then looks like it was moved down. So we have a reflection across the y-axis, and then we had a transformation along that vector, or x plus 0, y minus 3. So if I combine those two, I end up with this as a transformation. Negative x, y, minus 3. Now let's check to see if that actually works. A was at 3, 1. I apply that transformation, and I get a prime, negative 3, 1 minus 2, negative 2. Negative 3, negative 2. A prime works. Oops, I've got this backwards. It goes from a to a prime, so that should be y plus 3. My bad. So a was negative 3, negative 2. So a prime becomes 3 plus 3, so that's 1, 3, 1. There we go. I just had my a and a prime backwards. And it works. And that is the end of this lesson.